Hacker, let's try again. What do you think a limitation of this pencil case is?
It's at least 20 pencils.
Yeah, okay. Saying it can only hold so many pencils, okay? So we said it needs to hold at least 20 pencils. So we put 20 pencils in. Cool, good job, meets the criteria. Now we need to make sure it's small. A limitation would be that it can't hold 25 pencils. It can only hold 20. If we want it to be small and we want it to hold 20 pencils, we need to make sure it only holds 20 pencils. So we need to make sure it meets the criteria, but we limit it to only 20 pencils. Anything more, it doesn't work, so it's a constraint. Okay. Okay, Hun, why is research important?
Because they help us know that did other people do that experiment or to know more information of that topic or that experiment.
Yeah, excellent, great answer. So as Hun said, what we want to do is we want to look to see if one, people have done it before and we can improve on it. Two, to find as much information as we can. Why do engineers look at nature to try get ideas for their designs? Winter, what do you think?
What?
Why do engineers look at nature? Why do you think engineers look at nature when trying to help with their designs? Billy is an
idiot.
Yeah, don't say that. Don't call yourself an idiot. I don't think you're an idiot. You shouldn't think you're an idiot either. So don't call yourself an idiot, okay?
Yeah.
Okay, Billy is a clever person. Why do engineers look at nature? Why do you think?
So they could copy nature and do the things that is the same as.
Has done over years and years and years and years is engineered itself to be really good at what it does. We're going to talk about this later on in the year called Survival of the Fittest. If anyone is interested, have a look up of Darwin, Origin of Species, and try get an understanding of what evolution is and inherited traits are. Just as a little side note, I can send you some information on it if you really want. There's a good video, a good peekaboo video about all of this. Survival of the fittest is basically, if you think about a cheetah is the fastest animal in the world, right? And a deer. Now, cheetahs eat deer. Cheetahs run after deer. Deers run away from cheetah. If you're a fast cheetah and a slow deer, the slow deer, bye-bye, no more deer. But if you're a slow cheetah and a fast deer, no more cheetah, bye-bye. So what happens is, fast cheetahs and fast deer survive. Cheetahs get faster, deers get faster. Cheetahs get faster, deers get faster. Faster, 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 faster. And over a long, 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 long time, what happens is you only get fast cheetahs and you only get fast deer. All the rest are dead. They're all gone. They don't survive. So survival of the fittest is those that are best able to survive will survive. So the same situation is going to happen with animal traits and animal behaviors. The reason they are so good at doing things and the reason that engineers will look at why they're so good at doing things is because they've got so much better at it over years and years and years that we should copy them. Think about Velcro. Who knows what Velcro is? You know, you stick two bits together and it goes shh, shh, shh. Where do you think that comes from? Or where the idea came from? Seeds. Came from the idea of seed. Yeah, Trixie. Trixie, where do you think that came from? Sorry, Trixie, you've just frozen there, unfortunately. So an idea comes from seeds, okay? A lot of seeds will stick to animal fur and engineers decided to copy that idea. Okay, let's move on. So I want to have a look at this question. And this is something that engineers do a lot, is they will look at something and take what they know and what they like to explain one of their answers to us all. This is because Plants were left in a dark room. When it is dark and there is no sunlight, plants will use oxygen to breathe. If there was sunlight, they would use CO2. So there was less oxygen for the grasshoppers. Okay, does anyone have any questions about that? Does anyone understand that? Yeah, Pro, do you have any questions? No? Cool. So that is a scientific principle right there. That is something that engineers will use to their benefit when they are trying to design something. What they say is like, hold on, okay, what do I know? What do I know about this? So if you were to think about why a grasshopper would die sooner than the grasshopper here, you would understand that, okay, well, hold on, it's a dark room. The plant's actually going to take up more oxygen. That's not very fair. What would you think would happen if the plants were not left in a dark room? You can give me an answer. Why were they left out in the light? Hello, can you all hear me? Can you hear me? Please give me a thumbs up. Okay, thank you. Not sure what happened there. I think my computer froze. Okay, cool, good job. Okay, so to quickly go through this again. So scientific principles will be used in order to help engineers come to an understanding. If they were to ask a question about, okay, hold on, the criteria is I want grasshoppers to survive for a long time. What do you think the engineers would do? If you were to take experiment X and Y again, what could you do to make the grasshoppers survive longer? Billy, stop making weird faces in the camera. Billy, what could you do to make a grasshopper survive longer in the container like you see?
I will replace the silk containers with a glass container with some holes in it and some water and some food.
Yeah, some water and some food. Good stuff. And Joey, can you hear me now? Yeah, this design process. Now I can give you this when we go back to class and we can fill it out. But what I want you to do is have a look at all of these steps, identifying the problem. We looked at this in a lot of detail, exploring the problem, then designing. So before you even start designing something, there's two steps. There's identifying what the problem is and exploring the options to how to solve the problem. So this here is, remember we were talking about making a question. What question does this solve? What am I going to do with my engineered solution? What is the point of all this? Exploring is the research that we were talking about, the research, the looking for patterns, all of this. So we need to do those two steps before we even start designing the solution, right? So have a look here. You've got these sentences on your left. Which sentence correctly goes in identify the problem? You don't know? Okay. Cherry, what do you think? So we identify the problem. What are we going to do? Which sentence best describes this one? Sorry, Cherry, what did you say? Can't hear you. Cherry, can't hear you again. Okay, Lambi, what do you think best describes the problem? I know. Baldy, look at the picture below. In identify the problem, we need to put a sentence here. So is it?
Yeah.
On the left-hand side, you have test your solution, research what others have done, So describe which sentence goes in this box.
See well.
You can't see well.
In the box had the little words.
Let me try to fix this for you.
Oh yeah, describe the challenge.
Describe the challenge. Yeah, okay, there we go. So yeah, if you were to think about what goes into this box in the corner to when you are identifying your problem, For me, what you would do is you would choose the option, describe the challenge to be solved, including the limits and constraints. Okay, what about explore? What do you think will go in explore? Let's try someone else. Let's go Pumpkin. Mr. Pumpkin, have a look. Yeah, what do you think goes in explore? Okay, no problem. Winter, what do you think?
Use your knowledge and creativity to come up with many solutions. Choose one idea and draw or make a model of it.
No. Wrong one. Katie, what do you think? So you need to explore. What does explore mean? Explore means to look into or to find, right? So what sentence best describes explore? We spoke about it quite a lot. Pumpkin, yeah. What do you think?
I think evaluate how the solution work and think how to improve the decision.
No, not yet. That's too late. Too early. Yes, Winter.
Make your solution.
Make your solution? No. So we're exploring. We're not even designing the product yet. We haven't even designed it. Kimmy, what do you think?
Explore.
Yeah, explore. What do you think best? What sentence best goes into explore?
Research what others have done. Discover what materials are available.
Yeah, good job. Okay, so here I put research what others have done. Discover the materials. What? Sorry. Research what others have done. Discover what materials are available.